In this session, we see how to solve a problem related to AC sweep analysis. There are varieties of analysis are there in Pspice. So one such a analysis is AC sweep analysis. What type of questions can be what type of questions can be uh, solved using AC type AC sweep analysis? So, for example, if you consider construct an RC high pass filter circuit using Pspice with R is equal to 220 and C is equal to 0.33 microfarad and simulate for the frequency response curve. So this type of problems can be this frequency response means how the uh, parameters, so maybe gain, maybe voltage, output voltage changes with respect to frequency. So that is called as frequency response. Okay. So to do that, we require AC sweep analysis. Now coming to the next one, construct the following circuit and draw the frequency response curve after simulating it. Find the resonant frequency and show the calculations. So to do this type of things also, to solve this type of problem also, we require AC sweep analysis. And one more very important thing is in this particular circuit, we are considering one voltage source. This source is VAC. Remember, so for frequency response curves or AC sweep analysis, we consider VAC, not V sign. Here also, in this particular problem, we consider VAC. Let us start first simulating this one. Construct the following circuit using the simulator. So first we try this, then we go with the short answer question. Yes. So go to Pspice. Go to Pspice. Go to Pspice schematics, and then okay, consider in the circuit we require VAC, resistor, inductor, and one capacitor and one EGND. This is capacitor C, this is inductor L, this is resistor R, this is resistor R, and this symbol is given the name as EGND, E ground, EGND. This is what is called as, and this is what is called as current marker. Current marker. I means current marker. So it indicates that I'm going to take frequency on x-axis, frequency on x-axis, and current on y-axis. That is what it means. So what is the meaning of this current marker is my intention is to take frequency on x-axis. I'll apply various frequencies using this VAC. This is having a provision to vary the frequency, and this I means the current flowing through resistor R1, the same current flowing through L1 or C1 will be considered as the parameter on y-axis. Then if you draw a curve, we'll get a curve like this. In this curve, so the peak value at a particular frequency, the current flowing through the combination will be maximum. That particular frequency is what is called the resonant frequency. Resonant frequency. Okay. Now, how to mark the resonant frequency on the curve that we see now. First, you consider all the components, what all you require. I require resistor, place, and inductor L, you place, and C, place, and VAC. Remember, for AC frequency, AC sweep analysis, I'm considering VAC, VAC, then EG, and D. Place and close. So these are the components I require. I don't want anything else. So press escape and then zoom it. Now arrange the components: resistor, R, L, and C. This is what is that thing, right? So again, click on the zoom to fit page, and then you click on wire, consider wire, and interconnect the components. Interconnect the components. Okay, so components are interconnected. Now I'm changing the values of the voltage source. Here the value that I have considered is 1 volt, and this is 15 ohms, 10 millihenry. So how will you do it? So click on this, double click on this 1V, and this is 15 ohms. 15, no need to consider the symbol, 15, and this is 10 millihenry, millihenry, millihenry. And what is the value of the resistor, the capacitor? 0.1 microfarad. 0.1, 0.1 microfarad. Say okay. Now you consider the current marker. This is what is the current marker. This is the current marker. This is the voltage marker. If you put this voltage marker here, so it means my intention is to consider the voltage drop at this point as the parameter which should go on y-axis. No, but my intention is not to consider voltage on y-axis. I want to consider current on y-axis. So you consider current marker. Okay, current marker means the current flowing through the resistor R1 is considered as the parameter on y-axis. Now, so with this, the construction, everything is over. Now you save this with some name, and then go to analysis and setup. Go to analysis and set. Same thing here, there is a shortcut. Click on analysis and setup. Click on setup analysis and select AC sweep. Don't deselect this bias point details. Don't deselect this for any type of analysis setup. You don't deselect this. It means you are asking the simulator to maintain a database of all the values for which the simulator you are asked, it will maintain a database of all the values. Okay, click on AC sweep and click on this AC sweep. Okay, so linear means ordinary graph sheet, and decade means it's a semi-log graph sheet where x-axis is going to be ordinary axis, y-axis is going to be, yes, log x variation type of graph. That's a separate type of graph which is called as a semi-log graph. Decade means 1 is to 10. So that is this graph, and you no need to change this starting frequency, no need to change this ending frequency. You may consider it, for time being you consider this as 100k. Later, by seeing the variation, you can change it. Okay, so end frequency 100k and say okay, and then close. Okay, so you save it and then run. So once after simulating this, so you have to click on this. This is a probe window. Okay, so this will open. So you can see here, as I've shown you, you have to get a curve like this by taking current on y-axis and frequency on x-axis. You can see here, okay, current through resistor R1 is taken on y-axis and frequency on x-axis. Okay, so now you click on this toggle cursor all these particular things get highlighted. Now they're de-highlighted, you click on this, then all these things will get highlighted. If you click on this cursor at peak, you can see the crosswire has come, crosswire type of thing has come, where now the crosswire is at the peak of that curve. Okay, now there's a small okay tooltip type of thing, or small window opens, giving you an idea about five five at 5 kilohertz. This is what is this value at 5 kilohertz. Okay, this particular frequency is 5 kilohertz. At that particular frequency, the current flowing through that is 66.25 milliamperes. 66.255 milliamperes. So this is what is called as 5.0462 is what is called as the resonant frequency. It's called as resonant frequency that changes with the values that you are considering here. Now, if I take 50 millihenry here, 50 millihenry here with same zero point 0.1 microfarad. So if I simulate it once again, if I simulate it once again, okay, if I simulate it once again, see the resonant frequency shifted from 5 kilohertz to somewhere. You click on this toggle cursor, all these things gets highlighted. Click on this, then automatically it will show you the cursor at peak value. The cursor is at peak value, 2.2721 kilohertz resonant frequencies that much, and the current flowing through the circuit at resonant frequency is 49.795. So what is meant by frequency response curve? How the current is changing with respect to the variation of the frequency, that is called as frequency response curve. Okay, frequency response. How the gain is changing, that is called as, that is also with respect to frequency, that is also called as frequency response. Now to do that, we have to consider an analysis called as AC sweep analysis. In that, you have to give the starting frequency and the ending frequency. Hope you got an idea about AC sweep analysis, AC sweep analysis, how to select the starting frequency, how to select the ending frequency. Now here you can change the ending frequency to see more elaborated okay view of this. See the curve is not even crossing 10 kilohertz, so you can limit the end frequency as 10 kilohertz in this. Okay, so 10 kilohertz. Okay, so in that case, if you simulate it once again, it will consider 10 kilohertz as the ending frequency, so that you can see the zoomed version of the same curve. Okay, thank you.